Page 687, number 19. Find the standard form of the equation of the hyperbola. Find the center, vertices, foci, and asymptotes, and sketch the graph. Now, we know it's a hyperbola because we have both x and y squared. One of them's positive, one of them's negative. So we're talking about a hyperbola here. Okay, to start, let's group our x's and y's together so that we can complete the square. So 9x squared minus 36x, then we'll leave a space, minus y squared minus 6y, and we'll leave a space, equals, let's move that 18 over, so equals negative 18. Now before we complete the square, we have to factor a 9 out of both of these terms, because we need a coefficient of 1 in front of both of our x and y squared. I'm also going to factor a negative 1 out of both of the y terms. I'll leave a space again, equals negative 18. Okay, to complete the square, since I have 1x squared, I can take half of this value here and square it. Well, half of negative 4 is negative 2. Square that, we get plus 4. Now to keep things balanced, we just multiplied 9 times 4. We just added 36 over on the left. Let's add 36 over on the right. Likewise, let's complete the square for our y's. Since I have 1y squared, I can take half of this value and square it. Half of this is 3. Square that, I get 9. And really what I just added was a negative 9, so to keep things balanced, we'll put another negative 9 over on the right. Okay, so let's write this in standard form. That gives me 9 times x minus 2, quantity squared, minus 1 times y plus 3, quantity squared, equals, when I combine all of this, I get 9. Now if I divide every set of terms by 9, that'll give me x minus 2 squared over 1 minus y plus 3 squared over 9 equals 1. Okay, so now we've got this in standard form. Let's start with the center. Well, the center is defined by these two values in parentheses. So my center is at the point 2, negative 3. So let's start by graphing that point. So 2, negative 3 is right down here. Okay, now since my x's come first here, my parabola is going to look something like this. So to find my vertices, I can use the equation a squared plus b squared equals c squared. A squared and b squared are these two values down here, so 1 plus 9 equals c squared. So since c squared equals 10, c equals the square root of 10, which is about 3.1. That means my foci are square root of 10 units away from that center. Okay, so my foci are going to be 1, 2, 3.1 to the left, and 1, 2, 3.1 to the right. Now, I got a little ahead of myself. I should have found my vertices first. Okay, so to find my vertices, my stretch in the x direction is 1 unit. My stretch in the y direction is 3 units. And I can draw a box using those borders. Now what I'm going to do with this box, I can draw some asymptotes through the corners of that box. These asymptotes will help me sketch our hyperbola. So my hyperbola approaches these asymptotes, never touches them, just touches that box at that point, and then once again approaches the asymptote and never touches it. Same thing on this left-hand side. It approaches, touches at that point, and curves away. So my vertices are these 2 points right here. Those 2 points are, let's see here, this point will be 3, negative 3, and likewise 1, negative 3. Now let's write down those foci that we graphed. Well, those foci, if we go to that center and then add or subtract the square root of 10, we have our left-right dimension, and then negative 3 is the y-coordinate. Okay, so we've got the center, vertices, foci, we've sketched the graph. Now we need the equation of these asymptotes. Okay, now these asymptotes, we can see that it's going to be y equals something. So there's two equations, y equals mx plus b. Now getting the slope is relatively easy because, like in this case, we can go up 3 over 1. So one of those slopes is y equals 3 over 1 x, and one of those asymptotes has a slope of negative 3 over 1. So I have y equals 3x plus something, and y equals negative 3x plus something. And sometimes we can tell what the y-intercept is right from our graph. Sometimes we have to pick a point, like the center, to plug in place of x and y to find the y-intercept. In this case, we can get it right off our graph because, like this asymptote, if I go down 3, left 1, down another 3, left 1, there's my y-intercept of this asymptote, which is at 1, 2, 3, 4, 5, 6, 7, 8, 9, at negative 9. Now my other y-intercept, if I go up 3, left 1, up 1, 2, 3, left 1, here's my other y-intercept, which is up 3 units. So there's my equations of my two asymptotes. So we have the center, vertices, foci, asymptotes, and a sketch of our graph.